So when designing a DAC, what are the most important issues?
I would say the most important points are jitter. So it's also important to measure jitter correctly, and the Juergen Dunn work is just the start, is a very good start, but you can do more to measure jitter. And the next important point is very difficult to describe is the time behavior of the digital oversampling filter. So with these digital oversampling filters you can play around really a lot and can change the tonal characteristic of the DA converter enormous. Yeah.
And John, did you use a test, a jitter
well,
test?
I use the Juergen Dunn derived J-test, which gives you a pretty good idea of basic flaws in converter design. One thing I wanted to ask Juergen was, when you said that the time behavior of the oversampling filter, are you talking about the length of a filter or the actual characteristic of a filter, whether it's linear phase or minimum phase?
I mean both. It depends on the horsepower of your DSP and how good you have done the power supply. You will hear if you have many taps in the filter or if you reduce the taps. And the advantage, if you accept that shorter ringing filters do sound better, that means also less taps, and you accept that you have some aliasing in the upperst octave of your audio band, then you can reduce the tap and do not stress the DSP so much, so you can hear it. When we designed the digital filter, you can get similar bandpass curves that different only in the stop band, and even if you manipulate the coefficients for the stop band, these are still audible, because then the load for the FPGA or for any DSP who's calculating this filter is reduced.
Yeah, I have to get my head around that. You're talking about optimizing the digital filter for what's happening above the Nyquist frequency, half the sample rate, and that has audible effects below the Nyquist frequency.
Because of the load of the, which if you have a very precise stop band behavior, which looks very nice on the data sheet, you need more coefficients. And these more coefficients means more load and more work. Yeah.
So if the FPGA or DSP is having to work hard, you're getting what? Crosstalk from the currents in the various?
Yeah, you hear that the detail is missing. You get a little bit smear in the sound stage, and if you have less coefficients and less work, the sound stage really opens, and also the easiness of the sound stage is improved.
So at its minimum, a digital filter would have almost no coefficients, and you just have an impulse response which would be perfect up and down. But then you would get huge amounts of aliasing. But this is
the reason also why you hear differences if you make some DSP filter in front or inside the DAC chip. So you can create the same behavior of the digital filter in front, for example, with the HQ player, and can get with 4FS, 8FS into the DAC. So the DAC has less work to do, and this has tonal differences. Even the measurements are identical because you share the load. You remove the load from the DAC chip. But if you made a good layout and take care of this, and you are aware of this, with reducing the taps and ignoring the stop band perfectness, then you can get also very good results within DAC chip.
Except if you're going to spread the load amongst different stages, each of us doing mathematical operations, you're going to increase the word length at each step. And don't you have to then add div, or do you just truncate the longer word lengths, or what? Because
the thing is, if you
what I'm saying is that you're basically having to, there's a trade-off in these things.
Absolutely. So if you have a regular SPDIF or IAS interface, then you have to truncate at 24-bit. This is not a good idea. But if you're running USB between software player who does some of the oversampling, and you can get at least 32 bits into the remaining filter part of the DAC chip.
And then because of the longer word length, all the rubbish which is being produced stays so far below.
Yeah.
What I'm curious about, and I think a lot of people have a difficult time understanding or trying to understand how jitter affects the sound. And so, so if a DAC is poorly designed, let's say, and is jitter prone, how would that manifest itself?
You can measure this, how this will be audible. The normally Juergen measurement just give you how the LSB is distributed and how narrow the signal frequency does show up. But if you do frequency modulation analysis, you see then the jitter value over audio frequency, and so you get this graph is also in the Juergen book, and also the knowledge that in the bass response the ear does accept a higher jitter value than in the mid-range. So if you just tell a number 1 nanoseconds, 1 picoseconds, doesn't tell you nothing. So this behavior, this FM demodulation curve does give you much more precise insight what a jitter does look like. So if you telling me or give me just a Juergen graph, I can't really tell you what the DA converter will sound. But if you do have an FM demodulation, then you can clearly see that maybe the bass is loose or the mid-range is harsh. And so when the HDMI interface came out at one AAS convention, they played just the result of the jitter. So they removed the original signal and just played what is audible as jitter. Sure, you have to take into account that you have masking effect if the original signal is there. But this convention, I think it was in London, has given me a good insight what jitter does sound like in the mid-range, in the treble. So, but this graph I do not find in any magazine. Yeah.
Now you've mentioned what you're looking for as a DAC designer is minimizing jitter and optimizing the time domain performance. You haven't mentioned the frequency domain, and isn't that what traditionally we're supposed to hear?
Normally, some companies or some school books are taking care that the frequency response is flat and the ripple is 0 point something, and the attenuation at within the audio frequency is only very small. But for example, if you are looking at the NOS DACs, they have no oversampling filter at all, and they have minus 6 dB at half Nyquist frequency, so they have an obvious roll-off at 20K, at least 4 or 5 dBs. But if you listen to this type of DA converter, they are not dull at all. So because then the alias will creep in and give you this refreshment that the original frequency graph doesn't have.
Yeah. Now, in defense of those of NOS DACs designers, they say, well, with real music doesn't have a lot of energy once you get above 10 kilohertz. So the aliasing is going to be generally mild. I'm not sure if that's true.
It depends on the type of music. So this is the reason why we haven't done a NOS DAC, because it's very it depends on what kind of music and what level this music is mastered has an influence. If you have just a jazz trio, you get very natural coloration and timing, but if it's getting more complex, then it gets smeared. So with our low pass filter, we have chosen that it measures perfectly up to 17K, and from 70K the content gets really very low. So from 17K we accept some alias, but this from the listening sessions you can tolerate or work very good with all kind of music.
How important is the system context within which you place a DAC? In other words, I'm assuming that if you don't have a very resolving system, you may not recognize as easily these imperfections.
That's right.
Is that the case, or?
It is the case. So in the last years, I'm more focused also on the interaction between the components. So if you look at the typical data sheets, you find measurements for power amplifiers, for preamplifiers, for DA converter, but you have no idea what's will happening when you connect this together. And also the level is different. So the power amplifiers are calibrated to 2 volt at the output. The DA converter also different in the preamp. And if you hooked up all 3 products together and adjust the level that you have mastering sound pressure level at the output. So I'm also a mastering engineer, and if you're having 83 dB at your ears when mastering, this is the level you should master any final product. And if you adjust then your preamp to get this level, you can measure how the voltage does change, and then you can calculate the real dynamic range of each component and the real dynamic range if you combine this together. And so we will be surprised that there are some weak points maybe in your system that didn't show up if you just measure this one product. But measure all 3 together, you will be surprised that power cords and everything, or power supplies, that have a huge impact on the total measurement result. Yeah.
You remind me of something that the late J. Gordon Holt, Stereophile's founder, used to say, was that the problem with audio, unlike video, there's no defined playback level, there's no reference level. So the system is open-ended, and you don't actually know what the effect is going to be.
Yeah.
Yeah. But you're saying as a mastering engineer...
in mastering there is a level. It doesn't mean that all mastering engineers are using this level, but I do.
Yeah.
So, to bring up an old dead horse, so bits aren't just bits. In other words, you have there are still some people out there who will talk about determining the quality of a USB cable or some digital interface, and they'll say, well, all you have to do is make sure the data that's coming in is the data that's coming out, and if it's the same, everything else doesn't matter.
This is very, very thin ice. But the thing is, if you would hook up this USB cable, for example, in your measurement setup, you will not able to measure if the cable has a correct impedance of 90 ohm, and also the impedance of the driver and the receiver has the same characteristics. You will not have any things that you can measure, but you do not hear like this. So the transport has a power supply, and this power supply goes to the mains. The DA converter has a power supply that goes into the wall. So you have a backdoor, and you will be surprised about the influence of this backdoor to the system. Nowadays we talking about dynamic range 110, 120 dB, a very good system. And so even if you have a small stray capacitance of the USB input or of the power transformer, the loop that you have on the backdoor is greater than the original signal path. So if you measure then the complete system, you will really be able to measure some influences. Sure, there are still some points that I do not know if someone can measure it. For example, we have internal for the Jitter 3 different wiring, silver plated, copper plated, and solid core copper. It's clearly audible, but there's nothing that I can measure these audible differences. So over the years I accept that this cable has this kind of sound on a different system, so I'm confirmed that they has a specific tonality in the cable. Yeah.
Would you guess at reasons for that, John?
Well,
I'm sorry, I don't mean guess, but
when I was discussing this with my son-in-law, who's an IT engineer, and he said, well, surely they wind the cables to give maximum common mode rejection, and perhaps they don't.
No,
they don't.
When I first introduced a streamer in my living room, I measured it and it shows perfectly. Then I connected it, and suddenly also other sources have been disturbed from the sound quality, or in the former years when I hooked up the TV, and I thought, how could this measure be possible, because my digital input is galvanically isolated. I have had a sonic conversion with just 1.2 picofarad coupling capacity, but when I hook up this complete system at audio precision measurements, then I am easily able that there's a clear difference between real isolation, I mean optical isolation, or the very best transformers. They still have coupling capacitors.
Yeah. So when Michael is introducing a different USB cable in his system, he's introducing a different noise channel for the system as a whole.
Yeah.
And that will be different from cable to cable to cable.
For maybe 10 years ago, I have had a very, very good and learning experience. Was having poor power supply generators from batteries, and supplying just the transport or the DA converter preamp, and I learned a lot that this back path has massive influence. And when you hook up, for example, ideal, everything with balanced, so the maximum common mode rejection and the best isolation from the wall, means battery powered thing, then the influence of the cable is really shrinking then, shrinking to minimum.
It strikes me that when reviewing, let's say, a USB cable, which I try to avoid at all costs, but and one of the reasons why is because it's very system dependent.
Absolutely.
In other words, in my system it may do X, Y, and Z, but you take that same cable and put it in someone else's system, and it could be
that's right,
ABC. So it's hard to make any real.
And also you can, by intention, manipulate this backdoor. For example, the power cord has nothing to do with the primary signal path, but if you have silver plated or has a tint shielding, this just changes the tonal characteristic. This is a proof that this backdoor has really influence.
It strikes me, Juergen, that as you're an audio engineer, but also you're also involved in speaker design, amplifier design, digital design, and you're a mastering engineer, you are looking at everything as an entire system, not just I'm going to design a DAC and then ship it out of the door as it is.
But it's a learning curve over decades. So when I started, I was not able to do everything. But after over 30 years and still learning, and also still hearing, because I still make music and still record. So I really know how it feels when the tonality flows right. So it has nothing to do with distortion or something. It's just how it feels.
Very good.
This means the end?
Yes, thank you.
Okay.
Yeah.